all the students, how are you over there? Good morning. Today our lesson is mutually exclusive and non-mutually exclusive event. So our learning standard is differentiate between mutually exclusive and non-mutually exclusive events. Okay, student, when set A and set B does not intersect, so we write as A intersect B is equal to empty set or null set, N-U-L-L, null set. So it means that A and B does not intersect. So if this one happen, that means set A and set B are mutually exclusive. So today our main objective is probability of mutually exclusive events and our learning outcomes. That means after you study this lesson, you must know how to determine whether two events are mutually exclusive. Also, you must determine the probability of two or more events that are mutually exclusive. In short, a combined event A and B is known as a mutually exclusive event if there is no intersection between event A and event B. So A intersect B is equal to empty set. Okay, let's see the example here. Some table tennis balls labeled from 1 to 9 are put in an empty basket. A pupil chooses a table tennis ball from the basket at random. Let T is the event of getting an even number. U is the event of getting a perfect square. And V is the event of getting factor of 9. The relationship between the three events T, U, V are shown on the Venn diagram on the right. It is observed that event T and event V cannot happen at the same time. Thus, event T and event V are said to be mutually exclusive events. Event T and event U are non-mutually exclusive events, as the table tennis ball labeled with 4 is the common outcome for both event T and event U. Now, are event U and V are mutually exclusive? Please tell me the answer. U and V. Okay, please think first. Look at the U, look at the V. Are they intersecting? Okay. So, T and V mutually exclusive because they does not intersect. T and U non-mutually exclusive because they are intersecting. Okay? Understand? Okay, let's see this one. So T and V is said to be mutually exclusive because they does not intersect. Okay, does not overlap. They don't have the common element. Okay, common means same. Alright, T and U are intersecting at the elements 4. Belongs to T, belong to U. So T and U is a non-mutually exclusive. Okay? If they intersect, non-mutually exclusive. Does not intersect, mutually exclusive. Example, a student is selected at random from a school. Given P denotes the event the student is a male. Q denotes the event the student is female. R denotes the event the student wears glasses. Determine whether each of the following pairs of events is mutually exclusive and exhaustive. So, for set P and set Q, it cannot happen at the same time, and they make up the whole sample space. Therefore, P and Q are mutually exclusive. So when they cannot happen at the same time, mutually exclusive, then it makes up the whole sample space. It is called exhaustive. Okay, exhaustive means that it belongs to the whole sample space. Okay, that means number of the student must be equal to number of the sample space. Okay, it means that let's say your P and Q union, you consider all the elements is equal to your universal set sample space. So that is called exhaustive. Alright, okay, let's see B. How about P and R? And then R is the student that wear glasses. Okay, P and R can be the same person, as the male student can also wear glasses. Therefore, P and R are not mutually exclusive. P and R are also not exhaustive, as there are other possible outcomes in the sample space besides the possible outcomes of the two events. Determining whether two events are mutually exclusive, let's discuss this example. Cards of the same size are painted with yellow, white, red, blue, black, pink, and violet color. The cards are put into a box, and a student is asked to pick a card randomly from the box. So A denotes the event of picking a rainbow color card. B denotes the event of picking a non-rainbow color card. C denotes the event of picking a red card. Note that event A and event B cannot occur at the same time, as a card being picked can only be a rainbow color or a non-rainbow color, but not both. These two events are said to be mutually exclusive. If we list all the possible outcomes of these two events, we find that these outcomes make up the whole sample space. We say that these two events are also exhaustive. So event A and event C are not mutually exclusive because these two events can occur at the same time. For example, a red card can also be a rainbow color card. Are event B and C mutually exclusive? Please answer me. Okay, let's discuss the example. A worker in a factory is chosen at random. A is a worker with wages salary less than 2,500. B is a worker that needs to pay income tax. C is a worker who goes to work by car. Okay, determine whether the following pairs of events are mutually exclusive events or non-mutually exclusive events. Okay, A and B. Okay, A and B. Event A and B cannot occur together. Therefore, event A and event B are mutually exclusive. Okay, how about A and C? A and C can occur together because A and C are non-mutually exclusive. Okay, then event B and event C can occur together. Homework for today. Please try it now. 5-minute try. A fair dice is rolled. A list of events is given as follows. P is the event of getting a number that is greater than 4. Q is the event of getting an even number. R is the event of getting a perfect square. Determine whether the following pairs of events are mutually exclusive events or non-mutually exclusive events. A. Set P and set Q. B. Set P and set R. C. Set Q and set R. So you actually need to solve using intersect. Okay, try to find the common element. If there is no common element, it means it does not intersect. When it does not intersect, that means it is mutually exclusive. Let's discuss the answer. P and Q. P is a number that greater than 4. So you have 5 and 6, right? Q is event getting an even number. Number, you have 2, you have 4, you have 6. So it seems like you have common element between set P and set Q. Okay, intersect, right? P and Q are intersect. So when it is intersect, meaning that it is not mutually exclusive event. So P and Q are non-mutually exclusive events. Okay, and then we see P and R. P and R. P is a number greater than 4, which is 5 and 6, right? R is the event of getting a perfect square. Perfect square 4 lah. So, okay, just now you got 5 and 6 for the P, and then R you got perfect square, which is 4. So it seems like you don't have the common element, right? Does not intersect, right? So meaning that P and R is a mutually exclusive events. Okay, does not intersect, meaning that it is mutually exclusive event. Okay, how about Q and R? Q is event of getting an even number. Example, 2, 4 and 6. That is Q. R is a perfect square, 4. It seems like I repeat 4 just now, right? So it is intersect. So when intersect, so Q and R is a non-mutually exclusive events. Homework for today, question number 2. An egg is chosen at random from a farm. Okay, K is the event of selecting a cracked egg. Okay, L is the event of selecting a grade A egg. M is the event of selecting a grade C egg. Okay, determine whether the following pairs of events are mutually exclusive events or non-mutually exclusive events. Okay, A, K, and L. B, K, and M. C, L, and M. So please try on your own. Okay, later we will discuss the answer. Let's see the answer. So for case K and L, grade A is a L, K is a cracked egg. So sometimes when we choose an egg, even though it's grade A, you also can have the possibility that the egg is cracked, right? So it means that it can happen at the same time, isn't it? Grade A can also be a grade 8. So that means K and L are non-mutually exclusive events. Same thing happened to K and M. Okay, K and M, grade C and grade 8, it can happen at the same time, right? So K and M also non-mutually exclusive events. How about L and M? L and M, grade A and grade C are actually no intersecting. Grade A, grade C. So grade A is bigger and grade C is smaller. So there's no common element between them. So that means they are not intersecting. So when they are not intersecting, meaning that they are mutually exclusive events. Let's discuss question number 3. A tourist is selected randomly at Kuala Lumpur International Airport. R is the event of selecting a tourist from an European country. S is the event of selecting a tourist from an Asian country. T is the event of selecting a tourist from a Commonwealth country. Okay, determine whether the following pairs of events are mutually exclusive events or non-mutually exclusive events. R and S, are they mutually or non-mutually events? R and T, S and T. Please try it on your own. We'll discuss later. Okay, R is the tourist from European country. You know where is Europe, right? And then S is tourists from Asian country like Malaysia. So okay, so it seems like R and S cannot happen at the same time, so they are mutually exclusive events. And R and T, R from European country, T is from Commonwealth country. Okay, so they can happen at the same time, so it is non-mutually exclusive event. Okay, same thing apply to S and T. S and T, a tourist from Asian country, also can be a tourist from a Commonwealth country. So they are non-mutually exclusive events. Okay, for next lesson, we'll discuss further on the formula, the addition rule, okay, for mutually exclusive. Property of A union B is equal to property of event A plus property of event B. This is for two events. We will also discuss the property of three events. Okay. Property of A union B union C is equal to property of event A plus property of event B plus property of event C. Okay, we will also discuss more on exhaustive. Okay, exhaustive means if two events, let's say C and D are exhaustive, so the outcomes of the event make up the whole of the sample space. The whole of the sample space. They make the property of C union D will be equal to 1. So that is exhaustive case. So for next lesson, we will discuss further for the addition rule formula. Okay. With that, see you for the next lesson. Bye.